Hello and welcome to the 2017 Actual Tech Media Converged, Hyperconverged, and Composable Infrastructure EcoCast event. On today's event, we'll be joined by Cladistics, Unitrends, and Daytrum. My name is David Davis, and I'll be the moderator for today's event. I'm a 9-time VMware V expert, been in the industry a long time, writing, blogging, speaking for many years, and most importantly, I'm passionate about learning new and innovative technology, especially in the enterprise. In fact, the main reason that we at Actual Tech Media created this event series was to help educate the world of IT professionals, such as yourself, about the most innovative enterprise technology solutions available to you all in one place, do it quickly, and learn a lot in a very short period of time. So on this EcoCast, you'll learn about 3 different solutions in this space and get your questions answered and have the opportunity to win some very valuable prizes as well. Now, before we kick off the event, the EcoCast, you should know that there are 3 presenters today. Each presenter will speak for roughly 30 minutes. It's not a competition between the presenters. There's no winner selected today. Again, we want it to be a very educational event. So we encourage you to ask as many questions as you want. We have expert presenters. These presenters have many, many years of experience in the enterprise around all these different data center technologies, but specifically today, again, we're focusing on converged, hyperconverged, and composable infrastructure. So before we jump into it, let's do a little bit of quick housekeeping. First off, let's talk about prizes. Some of you might be interested in winning one of the 2 brand new iPhone 8 Pluses that we have that we're giving away today. We'll be announcing those prize winners in the Q&A box there on your console, as well as on Twitter. And then I'll be announcing the names of those winners verbally here on the event, typically right after our Q&A sessions that we do with each of the different presenters. I'll talk more about the prizes in just a moment. I also mentioned questions. We have a number of poll questions for you, the audience. We appreciate your participation in those polls, and I'll be sharing the results of those polls with you. And again, I want you to ask as many questions as you want of our presenters about their solutions. We'll be taking questions live, we'll be answering those live, and we'll be answering questions electronically as well. So use your questions box there on your console as much as you would like. Now, when it comes to social media, the event hashtag is HCIEcoCast, and if you tweet from your console, it will automatically append that hashtag to anything you tweet. You should know that the first time that you click that Twitter button, you'll have to do an authorization that's kept between you and Twitter. Of course, if you go over to another Twitter client, just append the hashtag HCIEcoCast. We'll be tracking the conversations around the event and this topic over on Twitter as well. And then also we have a handout for you from each of the different presenters. They have selected, it's in your console there, underneath the downloadable resources. There's one downloadable resource from each of the different presenters. You should also know that you can maximize or drag the presentation window of the slides to make it as large as possible. I recommend that you do that right now. That way when the presenters do live screen shares, when they do live demos, or they show architectural diagrams, one presenter today even has some videos to share. So make sure you maximize that presentation window so that you can see all of those things much better and much larger. Let's see, anything else that you need to know? HCIEcoCast is the hashtag. You can email the webcast to friends or colleagues from the console directly as well. Make sure you check out those resources from the presenters. And then before we jump into our first presentation, I have a little bit of state of enterprise convergence, if you will, my take to talk to you about. But before we do that, specifically about prizes, I need to make sure that I mention to be eligible for the prize drawing, you must be present on the live EcoCast to be eligible. So if you're not, if you disconnect, sorry, you won't be considered for the prize drawings. There are terms and conditions over at actualtechmedia.com. If you scroll to the bottom of the page, there is a link there to that URL on the screen, mc-prize-terms-conditions, that has all the legalese stuff related to selecting the prize winners. Winners do have the option to make a donation to a selected charity. We give a lot of prize money away to charity, and we love to do that. We have a number of selected charities that you see on the screen right there. And so we would be glad to donate the prize value of your prize winnings today to one of those charities. So best of luck to everyone on the prize drawings. When it comes to social media, this event is produced by Actual Tech Media. You can follow us on Twitter, and you can follow me on Twitter as well. I am David M. Davis, and I prolifically tweet a lot. So hope you enjoy those tweets, and most of them are about innovative enterprise technology. All right, so before we jump into it with our first presentation, I want to give you my take as a former IT manager, a former server admin, network admin, virtualization admin, about the state of the data center today. And I would encourage your feedback in the questions, about anything I say here. I want to make this conversational. I'll be answering questions and responding to any feedback, right after this presentation. So my take on the state of converged and hyperconverged and composable infrastructure in the data center today is that, all around, when it comes to the data center, when it comes to IT departments, expectations are changing, and they're changing big from the days, just 10 years ago when I was an active IT manager working in the data center, implementing, big infrastructure projects. The expectations today are far, far different, and they're getting, faster and different and higher expectations, all the time. So the business, what they're demanding in most cases is higher performance from the IT group, higher performance from the IT infrastructure, higher performance from the applications. They need higher scalability. They need to be able to rapidly scale up and scale down, if needed. They need more applications, and they need access to those applications faster. They need more availability out of the data center. They expect the data center to be up 24/7 by 365. Just like, everyone thinks that the cloud is, they expect the internal on-premises data center to have that same level of uptime, which is very, challenging to achieve. They also expect more, not just more capacity, but really unlimited capacity, for their data. And so these are some very high demands that are being placed on us as IT professionals. And at the same time, they're expecting lower costs out of the data center. I mean, maybe the CEO reads the full-page Wall Street Journal ad that they can get, the public cloud for just a few cents per hour. Well, hey, why can't, my internal data center provide that sort of low cost and low efficiency and high return on investment? They're expecting less infrastructure staff. They want us to really just have, one guy or a group of guys or gals that can really just do everything, kind of be the infrastructure engineer, the infrastructure admin, and just sort of take care of all of the infrastructure. They don't want it to be as complex as it used to be. And again, they want higher return on investment out of any money that they put into the data center. And really the theme of this, of course, is the age-old, do more with less. They want you to do more with less money, less people, and really maximize any technology spend. So what's the answer? Well, us as IT professionals, I feel like we need to find innovative technology that's smarter than ever before, that's more scalable, that's more highly available, that's higher performance, and far, far more efficient. Things don't have to be as complicated as they used to be. Things really can be easier if we have smarter, more scalable, more efficient technology. So that's my perspective. And the answer when it comes to any sort of infrastructure decisions for the future, to me, is going to be around converged infrastructure, hyperconverged infrastructure, and composable infrastructure. And that's why I think this is going to be a really great event today. On the EcoCast, we have, first off, Cladistics, Steve Connor from Cladistics, who will be presenting their composable infrastructure solution. I think you'll find it very intriguing. After that, we have Jordan Warsoff from Unitrends, who will be talking about the Unitrends hyperconvergence solution, especially when it comes to data protection. And then finally, we'll wrap the event up with Mike McLaughlin and Andre Leibovich, who are some real experts in what they call open convergence, which is a whole new form of convergence. So some really innovative presentations lined up for you today. I think that you're going to enjoy them and learn a lot. Before we jump into it, I've got just two quick poll questions for you here. So the first question is, how many people work in your company? And you just answer this question right there in the same slide area. Just click on the screen to select your answer. These are two quick kind of demographic questions to find out who's out there on the event today? So I'll give you just a second to answer that. All right, and it looks like most people have answered. I'm going to share the results with you. And it looks like very nice. We have a good range of IT professionals represented on the event today. 8% are in small businesses where they have up to 25 people. Let's see, a very good percentage are in the middle, between 100 and 5,000, roughly 40% of the audience, 50%. And then 25% have 10,000 plus employees. So some large enterprises represented on the event today. Thank you for answering that. I've got one more poll question before we jump into our first presentation, and that is, what's your industry vertical? So this is kind of a long list. You might have to scroll down in the slide area if your slide area isn't maximized. You select your industry vertical. All right, I appreciate you answering that. Looks like most of you have answered that question. Let me share the results now. All right, and hopefully you can see the results. Again, you might have to scroll down on the results if your screen isn't maximized. But we have, let's see, 10% are in healthcare, 8% manufacturing, 12% finance and banking, 24% in technology, 8% higher education, 5% local government. A real good representation of all sorts of enterprises and organizations represented on the EcoCast today. All right, and with that, I'm excited to introduce our first presenter on today's EcoCast. That is Mr. Steve Connor. He's the Vice President of Sales at Cladistics. Steve, take it away.
Perfect. Thanks, David. I appreciate it, and thanks for everybody for joining. So I'm going to spend a little bit of time just going over some ideas around composable infrastructure, and then the back half of this, I'm going to go through a demo just to show how easy it is to use platforms that are actually taking advantage of composable infrastructure. So with that said, when we look at the way the world is working today, and David mentioned this, a lot of people are trending towards doing things a lot more simply, right? And our cloud friends, Amazon, Azure, and Google are driving that. Today, a lot of IT professionals that we speak to in sales motions are just looking to get things into a more simple footprint. They want their administrators to be generalists. They want things to be done through the click of a mouse. And thanks to Amazon, we see that. Now, that's not necessarily the end-all, meets-all for any architecture. Not all workloads can go out there, and not all workloads are ultimately going to go out there, but it is kind of the theme and trend of what people are trying to achieve when they are looking at cloud-like architectures. And what we've seen as we've gone through our life cycle here at Cladistics is that converged and hyperconverged to kind of get you there, but there are other ways to get to the end goal of being more cloud-like on-prem. So when we look at the actual architectures that David was talking about, we've been going down this paradigm of going from more complex to simpler every step of the way. So when we look at the converged architectures, they did a great job of actually taking all of the components from multiple vendors and gluing them together. And what that did for us when we were working in these architectures is it actually gave us the ability to not really think about what we were going to architect anymore. It also gave us the ability in certain instances like vBlocks from EMC or other architectures to actually have one throat to choke, which was a huge advantage in the 2000s, the mid-2000s timeframe. And it gave us a pretty realistic idea of what applications we're going to do in those platforms. Now, the downsides of these guys is that it's still a lot of different pieces. I still had multiple support organizations that I had to speak to, and I still had a lot of specializations that I had to deal with. In this stack, if you look at it, I'm still dealing with networks. I'm still dealing with servers. I'm still dealing with storage area networks, and I'm still dealing with a hypervisor or virtualization. So it is a good first step towards getting to those cloud-like footprints that we see with Amazon. So as we move forward into those hyperconverged footprints that David was talking about, we made a leap forward, and it was a great leap forward. So you still obviously need a network for all of this stuff to work with, and those aren't necessarily integrated into those hyperconverged platforms. But what they did was make a giant leap forward and take all of those attributes in the middle, the storage and server components, and glue them together. and gave us a lot more flexibility and homogeneity in that footprint. So that took the storage administrator and the virtualization administrator and even those server administrators and allowed us to generalize those a lot more. It simplified that portion of the platform. In this scenario, we're still dealing with virtualization in most parts, so we're still going to have a specialty in virtualization. And it also gave us the ability to get a little closer to the application, not necessarily digging in deep, because there's a lot of moving parts still in this, but we're getting closer and closer to simplifying the way the application interfaces with this platform. So in this particular architecture, we're moving closer and closer to a cloud-like feel when we get into this. Now, when we put our architecture together, we decided to take a few steps from Amazon and actually took a couple of architectural principles directly from the way they do things. And we focused on networking specifically out of the gates. And we said, in order to be the right platform for on-premise footprints, we need to integrate all these components together. So when you look at Cladistics, and I'll describe how composable infrastructure works here in just a couple of minutes, we take all of those attributes, networking, compute, and storage, and intertwine them together using software. So in this world, we've taken the best attributes of Converged, the separate scaling points, and the ability to ultimately move incrementally in that world, and the simplicity of Hyperconverged, and lock that together into one platform. In order to do this, we also need to integrate the hypervisor closely with everything, because everything here is software-defined. So there is no more idea of software-defined networking, separate from software-defined storage, separate from software-defined data center. In our world, it's software-defined everything, and that includes the hypervisor. So we've integrated that as well. And in taking that last step towards composability, we also needed to make sure that we integrated the applications into this footprint. So as part of our overall management strategy and integrated into the platform, we have an application marketplace that allows you to actually pull templates and orchestration profiles to deploy applications that are pre-tuned and pre-orchestrated for the platform, very much like an Amazon footprint. So the goal here is to basically get administrators to a point where they can think about more business-oriented actions. They can think about just administering core-level functions inside the platform and move away from specialities. So that's kind of an overview of how this works. When we look at what composable means for us, we've done everything, as I said, in software, but it goes a step further. When we look at how we view resources, once you get into that virtualized platform, we don't look at servers, we don't look at storage or switches as independent components in the platform, and I'll show you this in the demo. We view them as pools of resources. And those pools of resources are basically predicated into fenced pools, and you then logically bind them to tenant boundaries. This platform is 100% multi-tenanted. You can do that both at the physical level and the logical level, because we want to behave very much like a cloud. And then when you do deployment activities, like a virtual machine deployment, a template deployment, or even an orchestration activity, in a composable platform, you simply have to say, as an administrator, execute, deploy a virtual machine, and the system will go out and actually analyze what's available in that virtual data center, the place where you're deploying that activity, determine where the resources are available, and deploy the system, just very much like in an Amazon zone. When you look at it from an underpinning infrastructure standpoint, it's standard computers, right? We're not dealing with custom hardware. We're not dealing with anything that would be something that you couldn't just buy off the shelf, and that's key to composability. If you're gonna move more towards code-oriented infrastructure, you need to make sure that the infrastructure that you're buying is something that can be supported by any vendor. So when you look at the way we roll this down, just to go through this entire slide, we made a design principle of taking the management infrastructure and exporting it out of the platform. So that Ignite control plane can either be delivered off-premise in the cloud or on-premise for security controls. In the virtualization platform, you have all those software definitions that we talked about. So you're going to have networking, storage, and compute software definitions done there. and that's going to be where all of your tenant boundary and all your administrative activities go on inside of the platform. And then as you go down into the physical layer, that's where you're going to see all those compute, storage, and attributes that you're going to need to work with from a hardware standpoint. But the goal there is to make sure that once this thing is set up, that you never have to even think about hardware moving. When you look at the platform, the other thing that we've seen when we talk about it, and David spoke about this earlier, is a lot of people are being stressed with not only do things simpler, but do things at less cost. So when you look at the overall lay of the land, obviously you've got operational costs associated with people, but as the hypervisor and virtualization become more of a feature than an actual product, there's a lot of people that are really trying to step away from paying as a core product for virtualization. So what we've done is said, as part of the Composable platform, we want to make sure that we have all the salient attributes of a VMware that will allow our customers to step away from VMware. So in this platform, we've designed and made sure that we have all the key attributes of ESX, vSphere, Standard Edition, and Enterprise Plus that allows you to step away. That also includes the attributes of SRM and NSX. So as we go through the demo, you'll see me touch on those as we go through that. But what that does is it gives you a rock-solid virtualization platform at all three tiers, network, storage, and compute, and you don't have to pay the tax of having a separate virtualization platform. It's built into the Composable platform itself. When you look at simplicity, you want to have an application that allows you to do everything from a single pane of glass, and that's kind of the utopia that we've been living with forever, right? People always promise single pane of glass. When you see, and I walk you through the demo, we're delivering that. So I can go all the way from hardware administration up to very high-order virtual machine administration activities inside the platform, and that's because everything here is software-defined. So when you look at the original Composable infrastructure, the part on the right, you're going to be dealing with these things. These are the different interfaces that you're going to have to use to manage, say, a FlexPod or a vBlock. As you walk the stack and move towards Composable, we actually get to the ability to actually use an interface that you can use to administer the entire platform. So by moving from Converged to Hyperconverged to Composable, and because we are doing software-defined everything, you have the ability to actually move towards that single interface for all attributes of the stack. And then what does that give us? So it obviously lowers the hardware cost because I don't have to pay a lot of different vendors, a lot of different things, and I'm dramatically decreasing the footprint. So because of the way the architecture is designed, we have obviously a lot of advantages because we're a newer architecture using Flash and NVMe. We also have a lot lower profiles, much like our friends in the Hyperconverged world. So that by itself is just dramatically going to decrease the hard cost. Because we don't enter in from a VMware standpoint and a lot of additional software licensing costs, those drop those hard costs down as well. So you're going to see a substantial drop in cost from a traditional VMware Converged or even a VMware Hyperconverged footprint as compared to our footprint. When you look at management, and we'll prove this in the next 2 minutes, you're going to see a dramatic drop inside of what you have to do. So there's no more specialists. You can do everything that you need to do, including hardware administration, from our platform or from our management interface. So what does that do? That gives you the ability to move those resources, those time slices, back into things that are more geared towards your business. And then, if you have looked at the cloud for things like time to market or just speed, if you're in development, I did see some of that in the poll, you need to be able to work in those agile sprints. And because this is a lot easier than setting up a converged architecture, we can get a platform set up and operational within a few hours and deploying templates and virtual data centers in a span of about 30 minutes after that. So it gives you the ability to actually do those types of things very cloud-like in your own infrastructure. And because we live in the federal government space, we are headquartered in Western Virginia. We've paid attention to all these things that we need to pay attention from a security standpoint so we can work with our friends in the federal government. And then from a use case standpoint, before we get into the demo, we see, because the way the architecture's been designed, that we have the ability to span a lot of gambits here. So I can get this architecture really small. to where I can service a remote office or branch office with no problems and still give you the enterprise features of the software. So I can get this into, say, a Lowe's data center inside of a Lowe's facility. And I can then span that up to support massive footprints for Splunk or Hadoop, in that they're going to be able to have, design footprints that are going to support multiple terabytes of ingest for Splunk. So really the only thing that constrains us is the idea of being able to design the architecture to meet your needs. So that's more just a conversation than anything else. But what we wanted to do here is say, hey, look, what we want to do is take this architecture. It is a change in paradigm. Have a conversation. Look at the use case that you're looking at, and then figure out the best way to architect it for you. So with that said, the proof is in the pudding. I want to spend a few minutes going through doing this live demo for you guys. So I'm going to share my screen here. Give me 2 seconds.
I really look forward to these live demos. I know it takes a little bit of extra time sometimes to bring them up or get them working, but seeing a real platform in action, there's just no replacement for it. So I do see your screen, Steve.
All right, perfect. So I've tried to position the best we can, so I'm going to do my best to give you the full Monty here. And I use multiple logins, so I'm just going to prove that I can do this from just about anywhere. So I'm going to use my Gmail account. And this is the cloud version of this. So this is a resident in Amazon. It's a container running in Amazon. So what we've got here is that single pane of glass I promised you guys with respect to all the attributes that we have in the infrastructure. So as you'll see when you come into this platform, you're going to see basically the dashboard, and it's showing you a bunch of resources. This is where I do most of my living, working, and breathing, because it allows me to see at a glance everything that's going on with every single location that I'm working with. So here, what I'm representing is I have 2 different locations, a prod and DR environment. Now, in our world, there are no clusters. So we don't have the idea of a VMware cluster or a Nutanix cluster or something like that. We have the idea of zones, and these are just resource pools. And when we create those, we create a pool of computers. That's these migration zones, and we create a pool of storage. And those guys are basically our foundation footprints that allow us to create virtual data centers. So if you can get your mind wrapped around that, which sometimes takes people a little bit of time, you're off and running. So when you set up the environment, all you have to do when you're starting from scratch is create these zones. And you go in and basically set up whichever computers you want to throw in. And this can be any number of computers. And you can see we have 2 computers here. But you can basically put any number of computers in here, and it's how many are ever in that data center, physical data center. And as you bring nodes in, once they're connected into the switching infrastructure, which I'll show you in just a second, you would simply add nodes, and anything that's identified, which is it's discovered by the switches, would show up here, and you can add them to any zone inside of the infrastructure. So right now I don't have any extra computers to show you guys, so we'd move forward. So for this demo, what I wanted to do is just walk through a couple of the key constructs, and I'm going to show you some very standard things that you would do in a traditional virtualization platform that I can do really, really fast in the 5 to 10 minutes that I have left. So we've got these constructs, and basically the only other thing that you'd have to pay attention to when you set this thing up is hardware. And here you can see that we've got, in this environment, like we discussed, you've got switches, you've got computers, and you've got storage. These guys are physically separated because we want to have the best of the converged environment, that incremental scale. So as I scale out, I don't have to worry about being locked to a node. In a hyperconverged footprint, I've got storage, compute, and memory locked in a node, so I always have to scale them together. In my world, if I need compute, I add a computer. If I need storage, I add storage. So as we scale these things out, these just go linearly to the right, and away we go. When you look at how we administer these things from a hardware standpoint, you can see here, we can do every hardware-based activity, including connecting to the EEPROM console of this thing from this interface. So anything that you would want to do to hardware, you can do from this interface, including connecting to the console. So no more installing third-party software, No more worrying about, do I have this right piece of software to update? It's all done through the console. Now, as I said, once you've installed the footprint, unless something breaks, you should really never have to come back in here, or unless you're adding new capacity. This is the only time you would ever potentially come in here to look at something from a hardware standpoint. From there forward, the only place you would be paying attention to would be these migration zones, which you talked about, and storage pools, which we talked about. And then once you've done those setups, the only other thing that you have to worry about are virtual data centers and doing your general activities. So, that being said, the key construct here and what the foundation of our logical tenancy is the virtual data centers. So when we look at virtual data centers, the idea of a virtual data center is just getting resources from somewhere. So I'm going to create one on the fly. So I'm going to do ATM, and I want to create a virtual data center for ATM. So I'm going to create a virtual data center, and I'm going to add a few resources to it. So what I want to do for the ATM data center is I'm going to make this relatively small, 10 cores and 10 gigabytes of memory. And all I'm doing is basically creating a fence for this data center to have resources that are dedicated to it. So what I'm saying here is for this particular data center, I'm allocating these resources from those pools, and nobody else outside of this fence can actually impact these resources. So these are mine. As you can see, when I add resources to both of those pools, DR automatically turns on for me. So the system knows that I've set this up in a configuration that allows me to do DR. So once I've set those allocations up, I can come in and just simply click Create Virtual Data Center. The other thing that we can do while we're here is we can actually see what we've got going on in these data centers. So my friend Alex is in here, and he's done some work here in his data center, but I can come in here and hover and see what's in use as well. So you can see Alex has set up a data center. He's not using anything in here. So I may come back in here as the administrator here and say, you know, this Alex data center, it's allocated, but maybe I'm wasting resources. So I can actually dial Alex down on the fly and say he's only going to get 10 cores. And in both locations, he's got 15 there. So I'm going to leave that at 15. And once I step out of those, it automatically updates the resources for this data center. So I'm not wasting resources in this Alex data center. And the administrator for the God administrator can do this for any data center in this particular configuration. So we've created the ATM data center. So we've got that rolling on. The other thing that we would need to pay attention to is how it's connected to the infrastructure. So we have a couple of options. In here, we can create virtual networks, and in our world, we don't have the idea of working with layer 2. So if you're working in VMware, where you're doing NSX or distributed vSwitches or anything like that, where you have to manage VLANs, upstream VLAN tags, that's all done under the covers for you. So in my world, to manage networking, all you have to do is know the basics. Be able to name a network, know the network address range, so whatever the range could be from 1 to 253, know a net mask, and know its default gateway, and then answer a couple of questions around whether or not you want to run DHCP, whether or not you want to run in bridge mode or networking mode, and then assign it to the data centers that we're talking about. So if I were to create a network here, and I want it to be specific for that ATM network, environment that we just worked, and it's coming off your screen, but I could actually assign this network specifically to the data center I just created for ATM, set this up, allow it to be tenanted because of the data center I selected, and then move forward with that. So here I'm going to do it for this JV test. And it picks the pools that were associated with it because we do full tenancy. Once you get to the end and you filled in all those scenarios, I can apply firewall rules to this as well because we have built-in distributed firewall capabilities as well, or leave that blank and just click Create VNet. So I can have any number of VNets in this environment, and it also allows me to do things like reuse of IP. Because these things are completely distributed and completely separated, I can actually have the same 10.10.10 network running multiple times in this environment, and the platform will handle it for you. So when we get through this, the only other thing that we need to do before we actually start deploying virtual machines is actually working and creating any firewall rule sets that you may want to have inside the platform. There's two ways to do this. I can create a network-based firewall rule set, and this, in our world, you'll see it's not bound to an interface. Everything is software-defined, so everything is logical. So that means when I create this rule and I assign it to a VDC or a virtual machine, if that virtual machine's system that it lives on fails, it will move to another machine through HA, but the virtual machine's network will follow it, and so will its firewall rule. So I don't ever have to worry about, did I actually put that firewall rule on that machine? We don't have that type of binding in this platform. You just assign it to the logical entities, and it follows it as it goes along. So this is traditional layer 4 stateful inspection type of rules. So you've got the traditional allow, drop, reject, incoming or outgoing, and you've got the traditional all TCP, UDP, or ICMP. So if you've done firewall rules in the past, this is relatively simple. You add whatever you want in this environment, click Create Firewall Rule, and then you can assign that to any virtual machine or any virtual data center as you move forward. We also have, as you saw here, the idea of application-oriented firewall rules. So in this world, in order to be truly composable and have complete microsegmentation, I have to have the ability to create groups of servers. And as you can see down here at the bottom, I have this idea of compute categories and tags. These tags allow me to say when a virtual machine is spinning up, it's part of the SAP group or the finance group or the sales group. And when those computers come up, they have that tag. I can say through application firewalls that I set a specific firewall rule that's for sales. And what that does is it allows me to create a rule set that's not predicated on a network, but a group of servers that will allow me to override whatever networking rules are associated with that virtual machine. So that gives me the ability to do microsegmentation at the networking level and also at the application level based on those tags. So I can create those rules. You can see we've got a few created here, one specifically for Splunk. And creating tags is simple, just creating different names that you would want to do. Certain virtual machines can have an unlimited number of tags, so you can get really creative in how you use these tags. Very similar to some of the constructs that you would see in VMware. So once you've done the basic setup, and you can see it's relatively easy to do, the only thing you have left to do is create virtual machines. So in our world, as we discussed earlier, we focus on applications. So we have a general marketplace where we create and maintain templates for every single technology alliance partner that we support. So you'll see here that if you don't have to or want to create or come out and do any of these template creations, we've done them for you. So when you get a standard platform from Cladistics, it will have an empty template library. All you have to do here is to come out and grab this one. We'll call this Windows Server 2016 ATM, and it will download this. And I can change the parameters on this while we're going at it. So I'm gonna up this to 4 and 8, and we'll deploy this. We'll download this template, save the application template, and what that will do is download it to my local template library. And you can come out and get any version of these templates from us at any time. So this saves you a lot of time and makes it a lot easier for you to come out and get things that have, core operating systems like Synos, but more importantly, maybe you need to deploy Splunk. We've already done that. Maybe you need to do Cloudera. We've already done that. Maybe you need to do certain Windows images. We've done that for you as well. So it gives you the ability to not have to think about certain configurations that you normally have to spin on your own. You come out here and get it from us. Once you've downloaded that template, you can come in and just deploy from it. So you have a couple of different ways to do virtual machines in our environment. You can import from a VMware template or a Hyper-V template, and all I need to do is have access to their vDisks, either via sys or NFS, and it's just a point-and-click activity. So you basically will come in here, select the vDisks from what type is and what version it is, and it will ask you for its mount. So you tell it whether it's NFS or sys, provide the information, and we'll come in and select the different machines and import them in. I can do it. I can also import from ISO, or I can use one of those templates that we created. So here, what I'm going to do is create a new instance off of this particular one. I'm going to call this ATM. I'm going to assign it to the ATM data center that we just created. I'm not going to assign it to any application groups because I haven't created them yet. I'm going to select a pool. We're going to put it in the production storage pool, and I am going to assign it to that production zone. I'm going to go into networking mode. I'm going to assign it to the production migration network. I'll throw a firewall rule in there. It's not going to really matter. And I'm going to let the system do its thing. So here, if I needed to create multiples, I could just tell it how many instances I wanted it to create here, and I could create literally hundreds, and it only takes a few minutes for it to do. For this particular exercise, because we're constrained on time, I'm just going to create one. And this will come back and tell me that it's creating the application. It will basically spin up the environment. It will install, because I told it to, it's going to sysprep the virtual machine, install tools on it, and bring it online for us. So while that's happening, I'm going to go through a couple more actions and I'm going to be done. So with a virtual platform, obviously you want to be able to turn on snapshotting. That's one of the standard things that we're going to want to do. And we're going to want to turn on VR. And we want those to be super easy. So here in Alex's data center, he has 5 working machines. So, and this working machine, I want to turn on local snapshots. So I can either take a snapshot, just because I'm getting ready to do a backup or I'm making a major change, or I can turn on local snapshots. So I just pick the increment that I want to work on. I keep the retention policy, which here can be unlimited, and I turn on snapshots. These snapshots are fully deduped and compressed, so they're super tiny when you do these changes, because we don't want to consume a lot of space on these guys, right? So I've just turned on snapshot, so it's done. It'll continue ad infinitum. If I want to turn on disaster recovery, we do disaster recovery based on snapshots. So all I have to do now is say turn on disaster recovery. It will go to the target pool in that environment that I've set up. So in this case, I only have one pool. I'd say how many weeks of snapshots I want to retain. We also have a heritage and backup. So we also have daily, weekly, monthly, and yearly snapshots that you can retain as well. This would help you, say, in a VDI environment, if you would have a ransomware event, to just recover to the day before the ransomware event took place. Once you're comfortable with these numbers, and I'm just going to leave them as is, you click on Turn On Disaster Recovery, and once the local snapshots are done, disaster recovery will lock in step and move forward with that execution and follow the local snapshot times. So now that machine, in a matter of just a couple of clicks, is turned on for disaster recovery as well. The only other thing that you would want to do outside of that is destroy things. So our machine is up. To get rid of it, I simply just go over here, delete it, and it'll ask me if I had snapshot. It would ask me if I wanted to keep them. I'm going to delete that machine, which will quickly get rid of it, and then I'm going to move forward and go down here and delete the actual VDC. So once I do that, I'm pretty much done. So in essence, the only other thing that I wanted to cover, support. We've got obviously the ability for a phone. We also know that we're dealing with a younger scene here, a younger crowd, so we have the ability to do chat messaging. And the cool thing that I love about this platform is we have this ability to turn on support mode. Because everything is software defined in this platform, because it's integrated through software, I can turn on support mode. And what that will do is allow my support organization to reverse tunnel into the platform and work with you in real time. And because you are supplying the keys, only when you give me the keys can we enter into your platform. Now, at any time that you're uncomfortable with what's going on, you just turn it off and we're done. The other thing is, if you've ever worked in a converged infrastructure and you had to compile logs, or even hyperconverged and had to compile logs, it's painful. In a composable platform, all I have to do is say send system reports, because everything's software defined and intertwined. You know, we'll actually send all the reports, including the network switching, hypervisors, blah, 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 and it's already up in support. So when you do that chat, they may say send the reports. It's as simple as a click and everything's up there already. So that's, from a demo standpoint, that's basically it. I can't make it any more complex. I've done every data center action that I could do in a normal virtualization platform in the span of about 10 minutes. So with that, I'm going to get back over to our screen here. And stop.
Yeah, great demo, Steve.
Hey, perfect. And that's it for me. I'll take any questions, and if there's anything that you, I think we've got one question online, so I'm going to answer that. Well, we've got a lot of questions. So how much time
we have
do I have?
lots of.
I'm probably pretty.
We have lots of questions here in the queue for you. I don't think we're going to get to all of them, but let's do about 5 minutes worth of Q&A. So let's see. The first one that I see that came in here is, about Cladistics. Is it hardware? Is it software? Kind of what's in this package? How does it work?
So that's a great question. So we have two ways to deliver this. The primary way that we deliver today is it's sold as a platform. So it would be hardware and software. And that the current platform, the hardware underneath is Dell. We are transitioning and working to make that such that you can be Lenovo and Supermicro. We also have the ability, if you've got great buying relationship with Dell, that we will sell the software as well. So you've got two mechanisms. Because we're software defined and I don't care about what's under the covers, you can do it either way. We've got really good buying power with Dell, so we tend to sell more on the appliance side, the platform side. But
okay. Another question is about networking. Is a network switch included with the platform?
So in the environment, we start off with a switch, but we generally recommend two. And a lot of the brains of the outfit is in the switching infrastructure. And that switching infrastructure is both in the hypervisor level and the switch. So a good example is in a storage environment, which is controller-based. Usually the witness lives in the storage controllers. In our world, the witness lives in the switches. And we do a lot of the control of those, of cycling with respect to the storage controllers through power cycles and things like that. So the switches are important, and they are part of the stack.
Very nice, very nice. Okay. Another question here is about like the licensing on the applications that are in your template catalog. For example, Microsoft Windows. Would they just pay a license to Microsoft as they consume those, or how does that work?
Yeah, so we don't have a licensing agreement with those partners. So generally what we do is we work to sell our platform with a partner, like a traditional reseller, that would also then provision those licenses through. So we work with a lot of partners throughout the country. But yeah, you would buy those licenses after you've deployed the virtual machine.
Okay. And the questions are coming in, honestly, faster than I can read them. So you're going to have to take some of these after our Q&A session here. But lots of good questions rolling in.
Yeah.
Yeah, thank you, everyone. So let's talk about, getting started. I see here on the screen you've got a low-risk test drive. What's the first step that people typically take?
So what we generally do, we have two ways to test drive this. So we have a virtual lab, and that's not Memorex. That's you would actually get access to an entire platform. So what we would do is get you engaged with one of our sales teams, and we would understand the workload and ultimately what you want to test. We can then get you engaged in that virtual lab, or depending on the requirements and things like that, we also have physical POCs that we can deploy. So we can get those into your premise, allow you to bang on the system and see that it will actually do what we say it will do. And then obviously, from a selling standpoint, we'd love to convert that either in place or sell you a platform. But that's basically what we need to do. We need to talk to you, understand the workload, make sure that we size the POCs properly, and then get you either into the virtual lab or into a physical POC.
Okay. And what are some of the entry points? So is it like their VMware license agreement is up for renewal, aging hardware, aging SAN? Like what are the entry points typically?
That's a great question. So we tend to see either greenfield projects, or if somebody is coming to the end of their VMware license and they're just not necessarily looking for that renewal, that's one. We've got one customer that's got a lot of hardware. It's 7+ years old. And they're looking to get out of both, actually. And then we've got other environments where they're just not getting the scale or the performance out of that. We had one customer where they tested us against bare metal SQL servers, and our virtual machines outperformed their bare metal SQL servers. So a lot of times they'll be looking at, we'll either see greenfield, we're seeing an environment that's aging out, or a customer of ours will have a performance problem, and we can come in and knock out that performance problem. Those are pretty much the entries. We also, in that robo configuration I mentioned at the very beginning, a lot of branch offices struggle. So this gives you the ability to have just basically a data center in a box that you can drop in and put into a branch office.
I like it. So branch offices, infrastructure replacement, aging hardware, and then brand new projects, brand new applications, maybe acquisition of a new company, and they have an aging data center that needs to be replaced. What about multi-data center, like multi-site? Does Cladistics work in that way as well?
Absolutely. So if you think about with Robo, you're going to probably have, we've got one customer we're working with that has 87 stores. So in that environment, we're going to see 87 stores in that interface that I showed you. So we would be able to administer and manage any number of those footprints from one pane of glass, especially if you're using the cloud version of Ignite, which we recommend, by the way. But
okay.
You will be able to manage, and it's not infinite, but we haven't broken it yet. So it's, to us right now, it's still infinite, but you can manage any number of data centers from that single footprint.
Very nice. Very nice. Okay, well, I think that's all the time we have for live questions. Like I said, there's a ton of questions left for you there. Thank you so much for your presentation today, Steve.
Thank you very much, and I'll answer all the questions right now. So if you've got them, keep a lookout. I'll be answering them online.
Okay, excellent. For more information, of course, visit Cladistics.com. And I have popped up on the screen the brand new On24 feature called Pulse Check. If you see something on your screen that looks like a thumbs up or a thumbs down, it's meant to just say, hey, are you out there? Are you awake? Do you have a pulse? So if you want to just click the thumbs up on that, I wanted to pop that up before I put up the next poll question on today's event. And so hopefully you see the pulse check. You said thumbs up, I'm awake. Thank you for doing that. And now the question on your screen is, would you like to learn more about the Cladistics cloud solutions for on-premises applications? So in other words, would you be interested in learning more about Cladistics? If you liked what Steve talked about today and all the benefits that Cladistics could provide, just say, sure, I'd like some more info. So I appreciate that. Cladistics appreciates that. And just click the button there that says sure. And we'll be starting our next presentation in just a moment. I want to point out on your console there is a resource from Cladistics, and it's called the Solution Brief on the Cladistics Enterprise Cloud Platform. So make sure that you check that out as well. All right, if you haven't answered the poll question, just, again, say, sure, I would like some more info on Cladistics. It's a really cool composable infrastructure solution. And with that, let's go ahead and move on with our next presentation on the HCI EcoCast today. I'm excited now to introduce Mr. Jordan Warsoff, who is a solutions engineer at Unitrends. Jordan, are you there?
I'm here. Are you there?
I am. Thanks for being on, Jordan.
Awesome.
Take it away.
No worries. Thanks for having me. So good afternoon or good morning, depending on where you are in the world today. What I'm kind of talking about today is backup. Unitrends, at the end of the day, we're all about business continuity and disaster recovery. So what the heck are we doing in a hyperconverged and converged EcoCast? Before you ask the question, I'll answer it for you. Basically, every time you're introducing new infrastructure or changing infrastructure, you're adding something to your environment. And the reason you're going with hyperconverged, as we've heard from many vendors today, is all about making sure you increase the efficiency, increase the capabilities you have, and kind of reduce your downtime and inefficiencies. Why is backup any different? People hate having to set up their backup schedules and all that stuff. So making it a simpler and easier way is exactly what Unitrends is trying to go in and help with by also protecting your hyperconverged with an alternative hyperconverged infrastructure. So you got a converged backup solution that's an all-in-one system that's designed to be able to meet and protect your hyperconverged introduction. So you can see you kind of have this mix of what you're going to be able to do. And why is this necessary? Well, what we see is today's kind of the less is more world is the way we describe it. Basically, our IT departments have less time, less money, and less downtime with increased risk, increased work, and more projects. So we're now more and more responsible for the operations of a business without being given the time, the effort, the simple human power, or the even efficiency to be able to do so. And it's getting worse. Now that IT is such an integral part of every single business, Data is growing dramatically. The percentage of businesses that are attacked by ransomware is there, so you not only need to protect yourself, you need to protect from incoming attacks, and downtime is ridiculously expensive. One great example was Delta last year. It cost the company over $150 million, just like it was a couple-hour outage. You can just imagine, this varies from place to place, but $730,000 about the average cost of a single data center outage. That's just an outage. That's not even counting like the recovery and all that stuff. So what kind of solutions how can you really combat this? And we kind of address this. It's the hyperconverged answer. Now, Apple is probably one of the first people that did hyperconverged for consumers. Now, obviously for business, terminal servers kind of came first, but Apple really took this idea in the consumer market. Instead of having your phone, your music player, your camera, MP3 players were really becoming a popular thing then. We combined it all together to get this all-in-one integrated piece. So you ended up with this solution, the iPhone. Whether or not you love iPhone or not, BlackBerry wasn't able to kind of compete and do this at the same level that Apple was. So by combining it and making it less effort in maintaining all these different pieces, Apple kind of showed what hyperconverged can do for the individual. Now, the same goes for one of our partners, Nutanix. Nutanix is a hyperconverged system as well. You're combining all of the stuff you see here today, and it's an exploding market, as I'm sure you've heard. Being able to combine your infrastructure is huge. So being able to protect it should be just as important. And that's why you shouldn't settle when it comes to your protecting your new or your current hyperconverged environment. And you need a backup solution that's going to be able to enable you to have no finger pointing, one of the main reasons of hyperconverging, less management overhead, another great reason, more flexibility, more uptime, more confidence, and more free time to frankly move on to other pieces of the environment rather than having to stick with this individual one. So you have a lot of capabilities and a lot of options here to kind of meet whatever needs you may have. So that's kind of what Unitrends is trying to provide. We try to provide an all-in-one solution that's going what I consider taking you to the new world. Just like Aladdin takes Jasmine to a whole new world, I hope that's the right Disney movie, Unitrends is trying to do that too. We've got this old world where your backup solutions, multiple vendors with tons of finger pointing, more management, and you got a lot of work setting it up and getting it right. There's little continuity. You don't have any assurance that your recoveries will work. It's on a Windows deployment that's susceptible to malware, and it's a fragmented customer support experience. With Unitrends and the converged ideology when it comes to backup, you got one vendor, one hand to shake, less work. You rack connect it and you go on with your day. You have the local and cloud continuity with recovery assurance, more security, a purpose-built hardened Linux platform, and a unified and higher customer satisfaction experience, providing more confidence in your recoverability. Go from having this entire stack that's just your backup to a unified solution on the right using Unitrends and possibly even the Unitrends cloud. The old world, you have to call and manage multiple vendors, multiple calls, multiple solutions. Instead, with Unitrends, it's just a unified solution that gives you this awesome customer satisfaction experience where your support is going to be all 7 by 24 by 365 Unitrends employees that are co-located with our development office down in Columbia, South Carolina. From the first chat to a phone call, you're always going to be talking to Unitrends employees, unlike many of our competitors out there. Not to mention we have one of the best customer satisfaction rates, holistic CSAT of 98%, and we only provide 7 by 24 support. And so what does Unitrends kind of provide in our platform? So we really have quite a few options. We have our Recovery Series physical appliance, an all-in-one physical appliance that is around giving you that storage, the server, the software to be able to back up and protect all sorts of stuff you've got in your environment. We'll go into that in a second. We also, if you don't like the physical server, not a problem, you can deploy our same software on your own environment and use your hardware to run our software. It can be deployed in Hyper-V, VMware, Zen server. We can even do Azure or AWS. We also offer Office 365 protection for SharePoint, SharePoint, OneDrive, and Exchange. And we also have a Boomerang tool, which I won't go into, but basically the VMware to Azure, AWS, and back DR or migration tool. So let's kind of get into the real meat of what we want to see, the actual presentation. So where does Unitrends fit? Unitrends begins with a what I call the kind of the easy deployment. You simply get the info you need to be able to run it from either the software or the hardware, give it an IP, and you're already logged in. There's no convoluted console screen or anything like that. You literally just give it an IP in the console, and then you can access it from any browser. From there, it's all about protection. What am I protecting? All sorts of stuff. We can back up your physical servers. We can back up your virtual machines. We can back up your NASs. We can back up your applications. You got all sorts of protection. We've even got Cisco UCS integration. We've got, the list goes on of all the stuff we can protect. And this means that your flexible environment can be protected flexibly with the Unitrends solution. Instead of being dependent on snapshots, you could use agents to back up those virtual machines. Or you can use the snapshots to give you the instant recovery. You can do agent-based to back up selected pieces. We can even back up specific databases within a SQL server. The list goes on of all the options you have. And then that also leaves you with the recovery. Once the backups are completed, we're deduplicating in line to be as efficient as possible with your storage, and you can recover individual files, whole machines, applications, wherever you may want to your heart's content. All that backup and recovery I'll show you in a demo in a second. But once you've done the backups and once you got the recoveries, what's more important after that is being able to get that stuff elsewhere. Because with a Hyperconverged, you are consolidating everything, so you do kind of want to make sure you meet that single location point of failure as easily as possible. And that's where the backup copy can come into play, where you can copy your backups to hard drives. Oops, looks like it jumped back on me. You can copy it to hard drives, to NASs, to SANs, even to tape, or some kind of cloud options. And then you can also copy it to off-site locations such as the Unitrends cloud or your own private site. So we're giving you a lot of options of where you want to send your data, and then once it's there at that secondary location, you can then do all the recovery you could locally. So you kind of see the flexibility, just a peek into the flexibility. You're backing up everything in your environment. You're copying it to all sorts of different media, whatever you're choosing, and then you can keep it for a long period of time and recover individual pieces as needed. Let's go ahead and take a quick peek at my screen to check out a quick demo of the interface itself. So this here is the dashboard, the main dashboard, so you kind of get a quick and dirty view. There we go. Into what it looks like. You've got your recovery assurance. It tells you the success or failure of your backups. You've got how well your stuff is replicating, any jobs that are running. All these tiles are completely configurable, and you can utilize them to back up and recover whatever you may need. Setting up a backup job is as simple as 1, 2, 3. I can come here, create a new backup job, and right away I just simply select the servers I want to back up. I can choose which drives I do and don't want to include, set what type or how frequently I want to run the backups, hit save, and that job is created. It's that simple. I can see the status of these backups all right here. I can see a green, yellow is for caution, and if I even want to, I can set up a data copy access job where I can automatically test the recoverability of my backups. And this doesn't just show you a login screen and say you're good. This goes into it and it verifies that content is working. It goes to the application level. Other products out there are just sufficed with giving you hey, here's a login screen, you're good to go. That shouldn't be good enough. You need to get in there using the credentials and verify the applications work. How many people have had a SQL server spin up, but the SQL databases are corrupted? It's such a common thing. I don't know why anyone would be okay with saying a login screen is sufficient for knowing that backup was tested. This can do it automatically for you and give you a nice report on how long your recovery will take. Not to mention, recovery is a breeze as well. Here's a backup. I can select it, recover an individual file. I simply browse to it, grab the whole directory if I want to, and simply set up the destination. Don't remember where the file is located? Not a problem. You can search your backups to find a specific file. Heck, you can even find a specific wildcard and say, I want to find a specific PDF. Come right in here, PDF. I can search for it, and it's going to search through my backups to find all the ones that have my PDFs. And here you can see all of them. I can select which ones I want to recover. And again, select with a target I want to send them to. It's kind of that simple, and that's kind of what we try to do, is we try to make sure that as easy as possible for you to be able to understand what's going on and have control over your backups. And we do that also with a ton of easy-to-use reports. You can see how much space you're saving using Unitrends. Here I can see my deduplication and data reduction rates. I can also even check on my compliance and see how long the recovery is taking, how old the data is. And so here I can see I want an RTO of 4 hours. It's up in 7 minutes. And I can set my RPO of 24 hours, and it is just shy of 12 hours old. So a lot of stuff, and I know we don't have a ton of time to show you a bunch of things, but basically you can kind of see we're deploying the Unitrends system within your network on your hardware, backing up everything, copying it to some kind of removable drives, tape devices, whatever you need, or copying it to another site, or both even. The choice is kind of yours to do and see wherever and whatever you want. And this is doubly important with hyperconverged solutions. Unitrends can be deployed in working with Nutanix, for example, but we can work with a bunch of other KVM and other integrated arrays, Cisco UCS being another one. We can go in, snapshot the hypervisor, take the VM, and still allow you to use your built-in hyperconverged storage replication. So that way you have everything taken care of. Don't want to use the Unitrends appliances? Not a problem. We can deploy within your hyperscale hyperconverged infrastructure, replicate them between them so you have your backups and your retention pieces, and then utilize the Unitrends cloud. Really make sure that you're fully thinking about how to protect your shiny new solution. It's often an afterthought and can be one of the biggest problems after a new solution. With every new technology, how to protect it always lags behind. Don't be left behind. So many disasters and other things out there could render your data center helpless. You want to make sure that you have the tools necessary to ensure that you can recover, and you can do that by protecting, securing your backups, testing your backups, detect if there's any ransomware or any other issues. Unitrends does that by default, no additional fee, and also being able to recover. These are all the pieces you need for continuity. You don't have to take my word for it. We've got tons of Unitrends customers out there that are happy to rant and rave about how awesome they think we are and how many hours we've saved them day after day. You can check out just one, for example, here. It's all over the place. Really, I encourage you to go outside what Unitrends does and Google us at Spiceworks, us and Reddit, whatever it is. You can kind of see a good discussion about what we can do to protect a variety of things in your environment. So I'll leave it with these 5 points, and then I'll leave the rest of the time for questions. What's Unitrends trying to do? We're here to provide one vendor, which means no finger pointing, less work, local continuity with that recovery assurance so you know you can recover and how long it'll take, a secure purpose-built hardened Linux platform so that you don't have to worry about those Windows SMB vulnerabilities, and a unified and higher customer satisfaction experience, all from one great support team and from the company that's been around for a while that knows exactly how to do this right and how to get it done well. And that's all I've got. Thank you so much for your attention and paying attention to me ramble on for a bit. Follow some of the social media or medias if you're interested. And other than that, I'll be happy to take on any questions you may have about protecting your converged or hyperconverged infrastructure and how Unitrends as a hyperconverged solution can enable you to ensure your backups are protected and you can easily recover and go on with your day.
Excellent, excellent. Great presentation. Thanks, Jordan. We do have a number of questions here for you from the audience. So you ready for some questions?
Yeah, born ready.
All right. How exact can you detect ransomware with Unitrends is one question that came in.
No, that's a good question. So we got two methods that we do it. One is we use machine learning to see how what your change rates are by standard. And if we notice that a lot of files are changing outside of compliance, we will flag you and give you a little alert that says, hey, this looks a little funky. Check it out. That's one option. The other thing that we're coming up with in upcoming releases, we're actually testing for entropy of the files. So we're actually checking. Most data tends to be somewhat structured, especially when it comes to, all these Word files and stuff like that. Encryption garbles that up. If we notice a trend towards entropy with the files that we're going in, we can send this an alert to you as well. So you kind of have a first pass approach that's using, I would say, like kind of surface level heuristics, and another one that does an actual scan and dives into your backups. So that way you're not putting a scan workload on your production machine. Great question.
Okay, cool. Another person says, currently we're using X backup vendor. Why should we switch?
I've heard many people complain about X backup vendor, so I understand. No. The main reason to switch to Unitrends is two pieces. One, the customer support thing is not a joke. You can try calling our customer support line. They pick up quickly. They're super happy to help, and frankly, we all want good support with certain things, but you want the best support when you know you're going to be in those dire situations. Yeah, if I have a server and the server vendor takes me, 20 minutes to get a hold of someone, it stinks, but it's usually not an emergency. If you need to call backup, your backup, your disaster recovery vendor, they better pick up fast and be able to help you immediately. And that's kind of my thought process with the support. Other than that, the recovery assurance is huge. Our recovery assurance piece, being able to know that your backups can be recovered and exactly how long is unheard of. Having an automated process so you don't have to manually go in and test your backups, I don't know. I think that's the perfect thing for trying to be more efficient with my time, especially when so much is being demanded of IT today.
Absolutely, yeah. Another question here is about, they say they manage IT for a bank. Can Unitrends help us with compliance?
Oh, yeah. We have a ton of people that we help with HIPAA compliance. We've got 7-year Sarbanes-Oxley. We've helped so many people with different compliances because of our long-term capabilities, our flexible archiving options. The list goes on and on as to how we can be beneficial. So we've got a ton of local and regional banks that love using Unitrends because of our capability and ease of use.
Okay. What about, let's see, I had a question. Can you back up Oracle databases?
Yeah, we got Oracle 11G and 12C support. We can even do some Solaris Oracle stuff. It's kind of ridiculous. We've been around for way too long. We even have stuff dating back to Windows NT that we still support today. It's kind of ridiculous. So HPUX, Solaris, SCO, SGI, Oracle databases are on the list. We do RMAN backups to help protect those databases that you really need. Okay.
Another question is about, how can we see it in action? What's the best way to get started?
Great question. Probably reach out to the Unitrends team. You can actually fill out a free trial on our website. You want to just test it out on your own. If you want to evaluate it kind of with one of our appliances or maybe with our cloud solution, you can reach out to the Unitrends representative. You can simply call into us. They're ready and waiting for your phone calls, or you can email, I don't remember the email right now, but there's a form on our website you can fill out. That's probably your best thing, just at unitrends.com. To get contacted by a sales representative, and they can help you out with the evaluation.
Excellent. All right, well, there's a lot more questions that are a little bit more specific in the queue. If you don't mind checking those out and get back to those folks, I appreciate it.
Not at all. I'd be happy to. Thank you very much.
Thanks, Jordan. Great presentation. Thanks for being on. For more information on Unitrends, visit their website, and I'm going to pop up our next poll question right now, which is, would you like to learn more about how Unitrends protects converged infrastructure? I'm going to leave that on the screen while we announce our next prize winner. So let's see here. Our next prize winner, or our first prize winner, I should say, this is for a brand new Apple iPhone 8 Plus. This is a new one that came out, and the winner is Raj Singh from Minnesota. Congratulations, Raj. We will reach out to you to deliver your brand new Apple iPhone. We've got another Apple iPhone 8 Plus to give away at the end of our next presentation, so make sure that you stay tuned for that. If you haven't answered the question on your screen, make sure that you do that now. That is, would you like to learn more about how Unitrends protects converged infrastructures? If so, just say sure. I would like to learn more. Sounds cool. And with that, let's go ahead and move on to our next presentation. Thanks for answering that poll. I'm excited now to introduce Mr. Mike McLaughlin, who is a Director of Technical Product Marketing, and Andrei Leibovich, who is the Vice President of Solutions and Alliances from Daytrum. Mike and Andrei, are you there?
Yes, we're here.
Yes, thank you.
Thanks for being on. Take it away.
Great. So today we are going to talk a little bit about the evolution of the data center and how we got into hyperconvergence and what lies ahead of hyperconvergence and why we here at Daytrum believe there is an evolution cycle going on, and that hyperconvergence was kind of the first iteration of this type of integrated architecture, and why we believe what we are doing is far better and far more scalable and more performant than traditional architectures in hyperconvergence. So with that said, let me take it on. So if you remember, in the past, applications used to run bare metal on standalone x86 servers, and we had individual hard drives in each one of those servers. Life was, simple but also very siloed. But things changed drastically when a company called VMware created hypervisor, or the ability to create virtual machines and run independent workloads on the same server on x86 platform. That enabled us to consolidate many of our applications on top of those servers. The problem is that we quickly figured out that those hard drives that were available in those individual servers were not enough to cater for the demanding applications in those servers. So eventually we started using SAN for that, and the biggest reason why SAN became actually very prevalent in the hypervisor world is because VMware also invented something called vMotion, which enabled you to migrate between applications between servers. I mean, this is a long time ago, but SAN was already available out there, but it was not very used. And because you needed a shared storage to be able to vMotion those applications between hypervisors, SAN became very prevalent. Now, I believe we're having some issues with the animation here, but I'll go ahead anyway here. So what happened is, once we start moving all those applications to the SAN, we quickly figured out that initially the SAN performed great, and we had the performance that was needed for all the applications running on the x86 servers, but soon we ran out of performance, right? So we needed multiple different SANs in different environments, and it was very hard to scale when there were silos, and a lot of complexity as well. But the biggest problem around performance was not solved. But then Flash came along, and we said, you know what, let's put Flash as a caching tier of our SAN and serve hot data from there. And that worked well for a little while, but applications got more performance hungry, and the whole virtualization became more prevalent in organizations. So some organizations, some companies, some vendors looked at this and said, well, this is not enough, so let's make it all Flash SAN and cater for the applications. Flash is very good at performance and very good at latency, but the real problem was never solved, which was a bottleneck with the SAN controllers. Most SAN solutions will have two controllers, and the fact that you still bottlenecking your performance behind all those SSDs is a problem. So some companies looked hard at this and said, you know what? It doesn't make sense to have this bottleneck. Let's move the controllers, that are physical controllers in the SAN time frame, as a software stack into the hypervisor and have SSDs on those servers locally attached and make it a distributed architecture. And that's how HCI was created. Some well-known companies out there are still, selling this sort of solution, and there are many other companies that are doing this. But the problem is, applications also have big data sets, and especially when you start thinking about Oracle and SQL Server, and those SSDs in the servers were not enough for those applications or for that data set. And clearly it became very expensive at that point in time to make all-flash hyperconverged solution. So what they did is they added disks, and they would create a caching mechanism to keep the hot data on the SSDs and then the cold data on the disks. So the problem with this architecture is, first, for hyperconverged solutions, you generally speaking need to buy their own hardware or their specific HCL, so there is a hardware lock-in. The second point is, in the same time frame, servers used to be stateless, so there was no data actually being hosted on the servers. The data was all on the SAN. So if a server failed, you just power on that virtual machine in a different server. You're not really concerned about data resiliency. With hyperconvergence, servers are suddenly stateful, so data is living in those servers. So if you lose a server, you actually putting data at risk. And to be cost effective, vendors will tell you to do 2 copies of the data across the cluster instead of 3. And there's a lot of discussion around data resiliency and how many copies of the data you should have in a HCI or a SAN solution. SANs have been using RAID 6 and N+2 parities for a long time, but a hyperconverged vendor is trying to convince you that 2 copies of the data, or what's called 1 FT, is enough for resiliency. The fact being stateless to stateful was a big change. Also, managing hyperconverged clusters from an infrastructure perspective is very complex. So there is a lot of metadata to be handled, and most vendors will tell you, we'll do petabytes of data, we do thousands of servers. Yes, that's all true. What they don't tell you is that those are all in small management failure domains or clusters, because it's very complex to manage all that at scale. Also, there is a forklift aspect. You can't bring your own environment. You need to forklift your environment, your solutions, your applications into this new environment. So generally speaking, you say start with a pet project. You can't just bring hyperconverged as part of your environment, of your solution. And because of this metadata handling, and also a lot of east and west traffic, so because all nodes talk to all nodes, many companies that are doing large-scale HCI deployments end up having to re-architect their networks to handle east and west traffic. Most data centers today are handling north and south traffic, so there is this aspect as well. I'm seeing a lot of things that hyperconverged created that seem sort of like not really good, but there is a lot of goodness also about hyperconvergence. So they solved a lot of challenges in the data center. So they simplified, they automated, removed zoning, LANs, all the complexity and silos that administrators had to handle in the SAN time frame were removed. And some of the hyperconverged vendors went further and automated like patch management, hypervisor upgrade, firmware and BIOS upgrades. And this is all great. That said, most of the hyperconverged vendors that are on the market today, they created a solution to test the market. That's why we call the 1.0 generation, right? And it worked well for them, and they found a few different workloads that were very well fitted, like VDI. But the real problem here is that most of them evolved from there. So there is a lot of bolt-on services on top of file systems, and as an example, that were not originally designed for that. Now, like adding compression, deduplication, replication, erasure coding, and all those services that are considered table stakes in the data center today. That said, they work. That is not saying that they don't work. Finally, you clearly can't scale in different dimensions, right? For the most part, when you add compute, you add in capacity. And when you add in capacity, you add in compute because the disks and the capacity are in each one of the servers. And some of them will also require strict networking. You need to, you can't really play with your networking vSwitches if you're using VMware as an example. It needs to be their own configuration, and there are issues if you actually make changes to that. So Daytrum was founded by a couple very early VMware engineers and some founders of Data Domain. And they looked hard at this problem and all the issues that hyperconvergence created in the data center. And they looked at also how companies were moving from SAN. And they created a solution that enables you to scale performance independent from capacity. So the same way hyperconvergence believes that flash should be on the host, and a software controller should also be living on the host. So we should leverage the power of Intel when it comes to performance and data services. They did the same thing. The only difference is that we wanted to make sure that the servers were still stateless, so there was no data at risk when there were server failures. And we also wanted to create a concept of primary and secondary storage, and that's what I'm going to talk a little bit here. So the solution that we created scales out linearly from a compute perspective, so you add more compute with local attached flash, and you can bring your own servers, your own existing investments in the data center into the solution. And it scales capacity with what we call data nodes. So you create a data pool that has global deduplication across this cluster. So what we actually effectively created here is a solution that enables you to have local access to the data on SSDs or NVMEs. Some of our customers have been using NVMEs for over a year now. So all the reads are local. And all the writes, instead of going across a pool of servers, one write goes local to the SSD, and one write goes to this data pool, and it's fully erasure coded with distributed erasure coded. So we providing the same type of resiliency that SAN provides today, instead of the two copies that hyperconverged vendors are saying that how you should handle your data. Now, because we also don't talk between the servers for the most part, there's no east and west traffic, so there's no major re-architecture or impact on the network. So it simplifies the solution, but at the same time enables you to have much larger clusters. So as an example, and I'm going to tell you a little bit later, you can go from one compute node and one data node to 128 nodes and 10 data nodes in a single unified system. Now, the beauty of the whole thing is that this is not only VMware, or this is not only Red Hat, and this is not only CentOS and KVM. You can run all hypervisors at the same time on a single platform. Sure, VMDK files only work for VMware, and certain files work only for Red Hat as an example, but many large organizations have multiple different solutions, and they can leverage this environment for all their hypervisors or for the entire virtualization set. Now, the interesting thing that I want to talk here is the concept of primary and backup data. And of course, this will only apply if all your data is living on Daytrum, which for many organizations will not be the case. There are multiple different solutions out there today in the data center. But if you think that the VMs are running on the servers and we have a copy of the data in each one of the hosts, deduplicated, compressed, erasure coded, and then you have a copy of this data out of this compute cluster, stored and protected in this data node pool, you effectively have primary data running on the servers and backup running on that cluster. So in many cases, we are replacing third-party backup tools used in the data center. But if you rather use your Veeam or your Cohesity or your Rubrik, you're more than welcome to do so. And in many cases, you have not only Daytrum in your data center, but you have other solutions there. Just for fact here, you hear many hyperconvergence vendors saying this is what web scale vendors are using today. It's not. This disaggregated approach of compute and capacity is what actually like Amazon and Facebook and Google are using today, at least for the past 7 or 8 years. This is actually what's being used in the data center. If you want to confirm that, just Google it. Look for Facebook Open Compute Platform and Bryce Canyon Shelves, and you'll see that most of those web scale companies are actually moving in the direction of disaggregated hyperconvergence. They tried and it did not work well for them. So just a little fact here. But we are also very happy with some of the announcements that we've made in the last couple weeks. So we did a audited performance benchmark with IOMark, and we are proud to say that we are the fastest storage subsystem solution in history. Compared to the fastest array out there, all-flash array, we are 5 times faster and lower latency. And compared to the highest performing solution in the HCI space, and that test was done with Optane SSDs, Daytrum is 10 times faster. So this is really groundbreaking in terms of performance and resiliency and scalability. And those tests, to be honest, didn't even hit the maximum that our technology or our solution can actually achieve. But it's not only about performance and resiliency, right? There's a lot of aspects to managing data centers, and that's where HCI really shine, which is the simplicity. So we built, as part of the solution, full VM awareness and analytics. So you manage your virtual machines and workloads at a VM granular level, like even the snapshots and backups, everything is granular. We have all the automation around one-click software upgrades, firmware upgrades, and the table stakes data services that are required today, like inline deduplication, inline compression, inline erasure coding. And as I said, we do believe that Flash or NVMe should be on the host, so we have the concept of data locality, so data will always be in the host where the application is running. We have encryption and multi-site replication, and if you're running VMware, our HTML5 UI is fully integrated into vCenter. If you're managing KVM or Red Hat, RHEL, you can use that as a standalone user interface as well. But for the most part, there's really nothing that needs to be done in the environment once it's configured. All the data services are on by default. We want to make sure that everything is very easy and simple. So as I mentioned, you can bring your own compute solution, your own data center environment, connect to the data nodes, and we deploy what's called a hyperdriver into your compute node, into your hypervisor, and from there you can start using the solution, and you can share also with your SAN environment. Go from 1 to 128 compute nodes and up to 10 data nodes with 1.7 petabytes effective. We are somewhat a new company, and I know you're getting a lot of media attention right now, but we do have, lots and lots of customers, and we have Fortune 100 companies as customers as well, and they are in all sort of verticals, and we see uptake in all of them. And of course, we couldn't be here without a rich partner ecosystem. We've been working hard on that, and trying to certify and validate and benchmark as many applications and as many partners as possible to make sure that we give you the feeling that the platform is supported and will perform under any conditions and supported by both vendors. Okay, so I think that was a good introduction to Daytrum and also to the evolution of the data center, why we move away from SAN to hyperconvergence, and what is happening in this space, and how we are trying to solve some of the gaps that hyperconvergence created. I would like now to invite my colleague Mike McLaughlin to talk about split provisioning and also give you a demo.
Thanks, Andre. So the last part of our session here, I want to just kind of cover a couple things real quick and put in context. I've got a couple of short demos that I'll share with you, and if there's more information, you can always request one from our website. But split provisioning is a fundamental architectural approach that we've adopted or put into the product to essentially allow you to scale compute or capacity independently, kind of the top and bottom of this particular slide here. And the two demos that I'm going to show you here, one is I'm going to essentially take an environment and add additional hosts into it and show you how simple that how simple that is. And then I'm going to take another environment and I'm going to add another data node into it. So I'm going to add compute nodes into one demo and data nodes into the other. And I think with that, we'll just let this roll, and hopefully the demos will present well. And if not, and if you'd like more information, I'd like to see it a little bit more in depth, feel free to get back to us and drill in on that. But for now, let's take a look. So the first demo, we're going to essentially start with an environment and add compute nodes. And I think if I click this button, it's going to begin playing here. So on this one, I've got an environment already set up, and I know it's a little small to see here, but this is my vCenter. I've got a host running over 100 virtual machines on it, and we can see here I've outlined the box. This is one of our Daytrum compute nodes. And what I want to do now is essentially expand this particular desktop cluster, for example, and I've got 3 other hosts in my vCenter environment that are sitting there ready to be organized into my problem space, into my solution that I want to do here. And each of those are also Daytrum compute nodes. What I'm going to do now is go to the Daytrum DVX dashboard, and this is the top level. You'll kind of see the stats here. I essentially have one data node and 5 hosts in there. There's the one that we saw that was already configured in. But if I go simply to the admin gear and I want to add hosts, here's those 3 hosts that I just showed you that were sitting sort of on their own in my vCenter environment. And it is simple as selecting those hosts, We're installing the DVX software on them right now, basically turning them into DVX-capable hosts in this environment. What's going to happen is we're going to install the software. It's going to discover the local flash drives that we see here. These are SSDs that are on those hosts that are going to be turned into local storage through our DVX software. And I'll basically say, go ahead and select the ones that were selected there. And what's happening now is those flash drives are essentially being integrated into the solution and being put in front of the data store that we manage in the overall DVX. So now that we've mounted the DVX data store, I now have my original host and 3 more that are basically part of what I'm trying to do here. And I can simply now go back to my top level environment and push those 3 new hosts into that desktop cluster, for example. All right, so now my one host that was sitting in there running over 100 virtual machines now has 3 more DVX installed hosts. And it really is just that simple to take hosts out of vCenter that are discovered that have SSDs in them and essentially bring them into service into the DVX. So we're doing this all within the vCenter environment. That's another thing, just from a simplicity point of view. We essentially stay within vCenter, and now we can see that we have this one data node, and now we have 8 hosts and over 100 virtual machines that I'm free now to move around and deploy those hosts as I want. So the point on that one was fairly simple. Hosts in vCenter with SSDs in them can be added to the DVX by simply having us push software onto those hosts and convert those SSDs into local storage onto our data store. All right, so if you think back to that split provisioning slide, that's the top level where we scale out hosts, and I can go up to 32 on a single data node or up to 128 in the DVX cluster. This next little demo presentation here, and this will just take a minute or two, basically is going to add capacity. So in my environment, I may have a data node, and here we've got a DVX with just one data node and about 26 odd terabytes of capacity. We can see that on the top left. And what I want to do is add another data node. I simply go to the admin gear and I say add data node. It looks out on its local network for other data nodes that haven't been configured yet. And all we need to do is basically select the one that we want, provide some IP addresses so we can talk to that data node, and say add it to the data nodes set. What's going to happen now is the 2 data nodes are essentially going to form a single larger data set, all right, and we can see them now in this window, and the second data node is rebalancing. So we're actually moving the data from one data node over the 2 in the environment right now, and that's all done in the background. So I essentially went from a 26 terabyte to a 52 terabyte environment by simply bringing a data node into my infrastructure, putting it on the same network as the first one, and having the DVX discover and configure it into a larger pool of data. Now, those network addresses that I gave on there also give me some more throughput to it. So as I scale out compute on the top line, like we just saw with adding compute nodes, or I scale out capacity on the bottom line, as I just saw with the data nodes, I'm also scaling out the performance and capabilities of the entire DVX cluster. And that's really it. I mean, that's just a little insight into how we're doing this. And the architecture that we have is essentially separating the host and the data and putting the actions at the right level. And that's part of the DVX open converged architecture that Andre kind of gave you sort of the roadmap as we've evolved into that. And I think with that, we're about at the point where we want to stop and take any questions. I know that we've been answering some as our session has been going on. Do we want to open that up for questions on the line now, or we can just continue to answer those off the Q&A session? I'm going to turn it back to you guys at Actual Tech Media.
Okay, yeah, great presentation, really cool demos. Thank you for sharing those. We do have a number of questions for you from the audience. I see that you have been answering some of them. Let's see what's left here. Question that came in here is there a plugin for vSphere, or how do I achieve that sort of centralized management?
Yeah, so actually, the demos that I just showed you, there is a standalone UI if you wanted to get to it without your vSphere environment. But we actually plug into your vCenter. Your vCenter, we essentially introduce the DVX to the vCenter. Our plugin goes in there. You never have to really leave that environment to manage your virtual machines, their storage, or the DVX. So yes, there is a plugin, and the vCenter plays a very integral role, as you saw in the demo there briefly, of finding the parts that we want to put together.
Got it. Very nice. Another question here is about the hypervisor support. What hypervisors do you support again?
Yeah, so we support today VMware vSphere, KVM with CentOS, and Red Hat Virtualization, Rev. Those are the three options that we support today. And we also support bare metal Linux with containers. So there are many companies out there that are looking at containers, and they start their journey into containers with virtualization. But over time, they want to harvest that additional 5 to 10% performance of running containers bare metal, and we can support that transition too.
Okay, excellent. What about the storage protocols? Like, what storage protocol does Daytrum use to communicate? I mean, for the hypervisor to communicate with the storage.
So interesting. So the storage protocol is actually, I'm going to say it's proprietary. We're presenting vDisks. So in the VMware environment, or even in the Red Hat Linux environment, we're essentially presented as an NFS data store, but that is only to the hypervisor. So there really isn't a storage protocol that has to be sorted out or set up. We essentially handle all of that. So the thing that you're really focusing on from a storage perspective is getting the virtual machines on our data store or on our mount point. So I kind of saw the question here. There's no fiber channel, there's no zoning, there's no LUNs, there's no volumes, there's no HVAs that have to be put in. Basically, we have a 10 gig Ethernet between our compute nodes and our data node, and we form the actual communication boundary, but we present that as an NFS repository to all of the hosts sort of above the line.
Yeah, technically it's a NFS loop, local NFS loopback.
Yeah.
Okay, so all that traditional storage administration with a traditional SAN, that all goes away.
Pretty much. In my demo, you saw how quickly I added storage and I added hosts, and I wasn't doing really any storage operations. I'm going to manage them at the virtual machine level. I'm going to create virtual disks through my vCenter or through my Red Hat Virtualization Manager, for example. Yeah.
Very nice.
Storage gets very simple.
Okay, and let's say that I wanted to use vSphere and move Daytrum into the data center. Kind of, what are the requirements? Like, can you walk me through the process of, say I have a traditional SAN and some vSphere hosts, how would that change? How would the architectural design change there?
So to get started, so you need vSphere 5.5 update 2 or later, so something relatively recent. Your vSphere host would need to have a 10 gig connection to the network somewhere that we could hook our data node onto. And it would need to have at least 1 to 10 internal SSDs. We have a requirement to have some flash on that host. So 1 to 10 devices, 800 gig to 16 terabytes in size. You kind of figure that out, because that's what's going to basically front the DVX data node. Then all you would need to do is put our data node into your network and introduce it to your vCenter, and pretty much everything from there you saw in the demos here would be to add the hosts or add more data nodes, and it would basically form that relationship for you. So the minimum requirements, again, vSphere 5.5 update 2, at least 1 flash device and 10 gig network. The vSphere host really needs to have about 8 core on it, so it has to be relatively, I'll say, not too old, but at least 8 core total in processing power, so that we can run vSphere and the DVX software.
Nice. And is the built-in data protection and replication, is that sort of replacing existing, say, backup and disaster recovery type solutions? Or can it?
It can, and I would say augmenting it is definitely in the program. Replacing it in some cases. So the DVX, the data management services, include local snapshots, replication to other DVXs. We've got a very robust and rich mechanism for building policies around that. You can get crash consistent backups, VSS application consistent backups, and we can get that down literally like to the 5 or 10 minute RPO point if you want. But we're not a full backup application at this point, and there are still some situations and environments where there may be platforms we don't support or applications that you want to integrate to. So I kind of look at it as the belts and suspenders, backups and snapshots, really to give you the best leverage of effectiveness and timeliness of what you're trying to do.
Okay. What about scalability? There's a question here about scalability. I know that Andre and I recently talked, and we did an interview about the scalability tests that you all have done. Can you refresh our memory? What are the official scalability limits of Daytrum?
All right, so scalability, a data node can support up to 32 compute nodes on it. All right, so you have to start with at least one compute node and one data node to form a DVX. So on the lowest end scalability, the smallest thing you can build is one compute node, one data node. On the higher end, that single data node can have up to 32 hosts attached to it. I can string up to 10 data nodes together in a pool on the back end, and as I get to at least the fourth data node, I can put up to 128 compute nodes into a single DVX cluster of resource. So we're well within the boundaries of what you would manage probably within one vCenter environment as well.
Very nice, very scalable. And then what if I run out of space or I don't want to pay for more capacity on premises? Can I move anything up to the cloud?
So that's a qualified yes. So we actually have replication to the cloud. That will be in our end-of-year release. So that has been demonstrated, and we've got it running in some sites right now. That is a capability that we essentially want you to be able to replicate from a DVX to a DVX or a DVX to a cloud-based DVX as well.
Okay. Question came in here about encryption. Is there any sort of encryption available?
Absolutely. The data services, data deduplication, compression, erasure coding, always on. All right. One of the storage administration choices that we still leave up to our users is whether to encrypt all the data or not. So a DVX environment has an encryption capability which right now will encrypt all of the data on the DVX, on the data nodes, on the compute node flash, and on the connections between the compute node and data nodes. All right. And so that's essentially a very simple thing that you can choose to turn on or turn off.
Okay. And I want to call the attention to the audience out there to the question on the screen. It is, would you like to learn more about Daytrum's open convergence solution? If so, just click sure right there. We appreciate you answering that poll question. Another question here is about what's the entry point for Daytrum typically? What's the typical use case where people say, hey, I really want to put Daytrum in my data center?
A good question. So the data node starts, as you saw in the one example here, at 26.4 terabytes. We are looking at possibly making smaller ones, but that typically you're looking at about, let's say, a 30 terabyte addressable storage for your primary and possibly snapshot protected data. Because we scale by adding hosts and bring host performance into the mix, I talk to my customers, I say the fun starts at probably 3 or 4 compute nodes, and that's where you're really starting to move past other technologies. A single host, single compute node, single data node, you can certainly start there, but the ability to move workloads around and expand and literally bring more horsepower in by adding hosts, I'd say at 3 or 4 it starts to get very, very interesting, and as we scale up into the dozens or more, we have some customers running some fairly nice clusters against single data nodes.
Okay. So if your SAN is outdated, needs replacing, consolidation, storage consolidation, are those common with Daytrum?
Yeah, typically we'll find it is either the technology refresh. Somebody bought some storage 3-4 years ago. Maybe they have flash out on their storage array, or they're refreshing their servers and they're going to get a little bit more horsepower there, and they're trying to figure where do I put flash in my new data center? Well, putting flash in the server makes sense to us, and those servers then can hook up to a DVX data node for the persistent copy, and it's very easy to basically vMotion over onto a Daytrum data store and take advantage of everything that we provide. We see that in consolidation. We see it in a lot of workloads that would run better if they could get sub-millisecond latencies on a regular basis. We have a lot of customers that once they deploy Daytrum, they're running their workloads on the host in local flash, and they're seeing really nice results both from a performance and a latency perspective. So it's a great time for a technology refresh and literally put flash where it belongs, in the host.
Very nice. And what's the recommended step for people out there who are interested? Is it to request a demo on your website, or what do you recommend?
I'd say that's probably the best start is visit the website, If the information there through product specs and white papers isn't sufficient to do a little background reading on your own, click the button and request a demo. We'd be happy to talk to you. I mean, you can certainly get an on-site evaluation. It does require a piece of hardware, so our DVX data node kind of gets the thing kicked off, and we can work that either internally or externally with you. But I'd say see if the information that you're looking for is on our website, or give us a call.
Excellent, excellent. Well, really great demonstration. Thank you so much. There's some more questions left for you there in the queue if you don't mind checking those out.
Yeah, my colleagues here are busy typing into the window, so we're double teaming here.
All right. Well, thank you, Daytrum.
Right.
And for more information on Daytrum, they've got a great resource right there on your console. You can click on. It is a Daytrum solutions brief on converging primary and secondary storage. And I want to remind you that poll question is still on the screen. If you would like to learn more about Daytrum's open convergence solution, just click Sure right there on the screen. All right, and I'll leave that up while I announce our final prize winner on the event today. We've got another iPhone 8 Plus going out to Chris Shaw from Ohio. Congratulations, Chris. We will contact you to deliver your prize. All right, before we wrap up the event, I want to remind you that we have a podcast at Actual Tech Media called 10 on Tech. You can subscribe to the 10 on Tech podcast via iTunes or SoundCloud. Go out and check out the podcasts there. They are intended to be short podcasts, 15, 20 minutes. We shoot for 10 minutes, but typically 15, 20 minutes. Some great interviews with some really expert technology innovators around enterprise technology. So make sure you check out the 10 on Tech podcast. And I also want to remind you about our next event. That is the Enterprise Cloud EcoCast that's happening on November 29th. Make sure that you visit events.actualtechmedia.com to subscribe to future event notifications and learn all about our ongoing event series around the MegaCast, EcoCast, and IT Virtual Summits. And with that, we've reached the end of today's Converged, Hyperconverged, and Open Convergence EcoCast event. Thank you so much for joining us, and have a great day. Bye-bye.